Discoveries made by AI. CRISPR lets scientists edit DNA, but the scary part has always been mistakes. If the cut happens in the wrong place, it can cause serious problems. AI is now helping prevent that. Researchers at MIT showed that AI can dramatically reduce errors in a precise form of gene editing called prime editing. On top of that, AI models that design CRISPR guides have reduced accidental edits by up to 90% in some tests. In simple terms, the edits are cleaner and safer. Scientists can now spot problems before running real experiments, not after something goes wrong. Hospitals have huge amounts of medical data, but privacy laws stop them from sharing it. AI found a workaround. Instead of sending patient data to one place, the AI model goes to each hospital and learns there. The data never leaves. Using this method, medical imaging systems have reached over 95% accuracy. Even more impressive, these shared models perform 80 to 90% better than systems trained in just one hospital. This allows hospitals to learn from each other without exposing patient records, which is a big deal for diagnostics and early disease detection. Imagine a lab that never sleeps and doesn't wait for instructions. That's what some materials labs look like now. AI systems design new materials, run experiments, test them, study the results, and decide what to try next. All automatically. Some of these labs are running more than 1,000 experiments every week. What used to take years can now happen in days. AI is also suggesting new materials up to 10 times faster than traditional research methods. Robots handle the physical work while the AI handles the thinking nonstop. Proteins are tiny machines inside the body, and they're always moving. For a time, scientists could only see still images of them. That made it hard to understand how drugs actually interact with proteins. AI changed that. New systems now model how proteins move and change shape over time. AlphaFold 3 can predict these movements and interactions with up to 98% accuracy. This helps researchers spot interaction points that were invisible before. In some cases, this has sped up drug-related research by 50 times, simply by showing what was always happening but never visible. Bacteria are getting better at resisting antibiotics, and new drugs have been slow to appear. AI stepped in by searching for solutions at a scale humans can't match. Some models have analyzed more than 36 million possible molecules and generated brand new antibiotic candidates. Early tests show success rates as high as 90%. With effectiveness similar to existing antibiotics. Even better, the time needed to develop these drugs has been cut by about 70% in some cases. These aren't recycled medicines. They're entirely new designs built to avoid known resistance problems. Concrete is everywhere, and it's also one of the biggest carbon emitters on the planet. The surprise is how AI stepped into a problem this old. Researchers at MIT used AI to analyze over 1 million rock samples, looking for materials that could replace traditional cement. The system identified alternatives that cut emissions by 80 to 95% while still meeting strength requirements. In parallel, AI-designed formulas have already reduced concrete's carbon footprint by around 40% in real-world mixes. This matters because cement alone produces more carbon than most countries. Small materials changes at a global scale add up fast. Turning a single photo into a full 3D object used to be extremely difficult. You normally needed multiple angles, specialized sensors, or long scanning processes. AI made it practical. SAM 3D can now reconstruct full 3D geometry from just one image, even when parts of the object aren't visible in the photo. In robotics testing, it outperformed leading models with a 5-to-1 win rate. In real-world environments, it reaches around 80 to 90% accuracy. even with cluttered scenes. This has immediate impact on robotics, simulation, augmented reality, and digital twins. Instead of scanning objects from every angle, systems can understand shape and depth from a single snapshot, saving both time and computing power while speeding up real-world deployment. Advanced math isn't just about getting an answer. It's about proving every step is correct, which can take longer than solving the problem itself. DeepSeek v2 tackles that by combining reasoning with formal proof verification. Instead of trusting its logic, the system checks each step against mathematical rules. On International Mathematical Olympiad-style benchmarks in 2025, it reached gold-level performance with near-perfect verification. The key shift here isn't speed, it's reliability. When a solution is produced, it's also formally validated, which sharply reduces silent errors that would normally slip through even expert-level mathematical reasoning. Diagnosing dementia isn't just about confirming it exists. The harder part is figuring out which type it is, and that process can take time and multiple tests. Researchers address this using AI trained on EEG brain signals, which measure electrical activity in the brain. Using a federated learning setup, the model learned from data across institutions without sharing patient records. In testing, it distinguished different dementia types with accuracy reaching up to 97% in some classifications. It also achieved over 80% accuracy when separating Alzheimer's, frontotemporal dementia, and healthy groups. The key here is accessibility. EEGs are non-invasive, relatively low cost, and widely available, making earlier and more precise classification far more achievable. Some heart conditions are hard to detect because they don't show up clearly on standard tests. Coronary microvascular dysfunction is one of them, and diagnosis often requires specialized imaging. Researchers at the University of Michigan trained an AI model to analyze a standard 10-second EKG and detect hidden patterns linked to this condition. The system produces results in seconds and identifies cases that traditional methods often miss. What makes this important is accessibility. It doesn't rely on new equipment or longer exams. It extracts more information from a test doctors already use every day. 1. Protein binding in seconds. This one reshapes timelines. Predicting how proteins bind with drug molecules normally takes hours or days of heavy computation. Boltz 2 reduce that to seconds. On a single GPU, it predicts protein structures and ligand binding in roughly 18 seconds, while reaching accuracy comparable to physics-based free energy methods. In practical terms, that's a speed up of around 1,000 times. This doesn't require lab testing, but it dramatically narrows down which molecules are worth testing at all. Drug discovery shifts from slow filtering to rapid screening, allowing researchers to explore far more possibilities than before.